Hey guys, and thanks for tuning in again to one of my kit building videos. Today we'll be building a small DIY power supply kit that I got from AliExpress. It's a 0 to 30 volt linear regulated power supply. It does 0 to 30 volts, as I said, and 0 to 3 amps, which is nice. I've laid out all the components and made this picture of all of them, so you can see what you get in the package and how to identify them. Basically, you have a bunch of resistors, different values, some diodes, potentiometers, wires, some capacitors, electrolytic and ceramic, a couple of ICs, op-amps, and a bunch of transistors, and of course the main PCB board. That's also handy for beginners is this small resistor reference card with which you can tell what resistors you have and place them accordingly. So if you're new, this will help. It helped me, but I double checked with the multimeter all of the resistors just in case. So yeah, let's get started building this thing. It's gonna be lots of fun, at least for me. Now I'll try to keep this video as short as possible, so I'll be fast forwarding through most of the soldering process, stopping maybe along the way to show you some tips and warn you about some things that I think are worth mentioning. But other than that, it's gonna be hopefully a short video, so fingers crossed. Now, as you can see, for the resistors, I take them by pairs, so, well, in groups. So here, for example, I have 5 10K resistors. When I get to a resistor, I check them out with the multimeter, for any case, check where they're supposed to go, how many of them are there, and I proceed to put them in, solder them in. Then I go to the next set, and the next set, and the next set. If it's a single resistor, I would put it in single. That way I won't make a mistake, you know. It's maybe too much, but this is the way I do it. And there we have all the resistors soldered in. It wasn't too bad. You just have to prepare them previously. I arranged them by value from smallest to largest, so I was going from I believe the smallest one was 33 ohm and the largest one was 270k ohm. So next I'll try to tackle the diodes that are over here. One quick note about the diodes and how you should put them in and which ones go where. You can actually tell the values on the diodes themselves, but they're so small that you'll probably have a hard time seeing it. So the way I recommend it is you have 4 really small ones, 2 a bit bigger, 1 a bit bigger, and 4 large ones. So the 4 smallest ones are the 4, 1, 4, 8. They go 1, 2, 4, 1, 4, 8, 3, and 1 more somewhere. And here, yeah, that's 4. 2, 5V1, 1, 2, 14004, that's this one, and of course the large ones, 1 and 5408 are these ones for the bridge rectifier. So, and also the diodes, I'll show you the smallest one, how small it actually is. Come on, I don't know if you can focus even. They have a small black line on one side and none on the other side, and that black line corresponds to the white line on the board. So black line should go here, 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 and everything else is basically the same as the resistors. You just have to keep in mind the polarity, because they are polarized components, so polarity does matter which way around you put them in. You have to be careful with these, not to bend them at the very base, but bend them a bit outwards. There are specialized tools for this, but I just use my hands. They're not that heavy that they can't bend by hand. Well, that's all the diodes soldered in. These ones were a real pain to solder because their leads are so thick that they take the heat out of the soldering iron immediately. So I had to use a bit of solder on the tip first, and then I put the soldering iron to the tip and the hole in order to get a better thermal connection going, and after that it went in good. Also with the capacitors, bear in mind that they are polarized components, so this small stripe on the side indicates the negative, which is also hashed on the board itself, on the silk screen. So make sure to put them in the correct way and you should have no problems. And also positive side is always longer than the negative, so that's another way of knowing if you put them in correctly or not. The ceramic capacitors also have labels on them. You can read them properly, it's no big deal, but their labels are different from the labels on the board. So 101, we have two of them, that's 100 picofarad. 331, that's 330 picofarad. 104, that's 0.1 microfarad, and 224 is 0.22 microfarad. Now, this big one is gonna be mounted, has to be mounted on some sort of heatsink. Well, I've seen people use like small heatsinks like this and attach a small 24 volt or 12 volt fan on it and attach it to the back and use it like that. That's probably how it should be mounted, but I'm not gonna do that. I'll be using this. An old AMD CPU cooler. So I've already drilled a hole and how do you say it, tapped it. So the 3mm screw that is provided goes into the hole, like so. And I'm gonna put the transistor like so, screw it in, and put some heat shrink and wires on the leads and put them back into the respective leads. So solder the wires inside here and solder the other sides over here. That way it's gonna be always off the case and cooled properly. Also, I'm gonna, for the moment, use a separate 12 volt power supply for this fan, but eventually I'll get a buck converter of sorts, so I can step down this 24 volts from here into the 12 volts I need for the fan, and also 12 volts for the display I'm gonna use, but that is probably gonna be in the next video, because as I said, I don't want to keep this video very long. So I'll proceed to solder in the transistors. And there we have it. All the components are in their place, everything's soldered in. I got a 24 volt AC transformer. Well, I've tested it out, it's not 24 volts, it's actually 28 volts, but hopefully that won't be an issue. We'll see. I've added the pots on these wires. So this one's for voltage, this one's for current. Added two leads, a bit chunkier wire, with some crocodile clips on both ends, and connected them to my multimeter, which is at the moment some cheap Chinese multimeter. I've ordered the Unity 61. No, U61E, yeah, I believe, from eBay. Should be arriving within a couple of weeks, maybe month. You never know with those shipping times, but it's finally time to test it out and see if this works at all, or we'll get some magic smoke going. We'll see. I've got the transformer connected to this plug. I've got the fan from the CPU cooler connected to a 12 volt adapter. I've decided not to put in the power, what's called, regulator for the 24 volt fan over here, because I won't be using 24 volts ever. I'll be using a display which uses 12 volts, and I'll be powering this fan from this port, because this puts out around 30 something volts DC, these two pins, and I'm gonna connect a buck converter or something like that to get 12 volts and power the fan and the display. From that should be enough. Or maybe I'll still use this power transformer. Probably not, probably I'm gonna power everything from one connector. But it's time to see whether this thing works. 3, 2, 1. I saw the LED flicker for a second, and I'm getting minus 0.01 volts. First thing you have to do is adjust this small potentiometer so that you get 0 volts. Again, this meter is not that accurate, so I don't trust it that much, but anyways, let's zero it out. Let's see. That should be 0. And my amps are set to maximum at the moment, and I'll slowly put up the volts, see if it works. And yes, I'll just put this to 20. Yes, it's alive. I'm really happy that this works. $200 volts. Let's see how far up it goes. 30.4, 30.5, which is perfect, even with the 38 volt transformer. Yeah, I'm satisfied with this. Let's try turning down the amps. Well, there's no load, so constant current mode is not triggering, but let's try adding a load. Now for the load test, I had to improvise a bit because the amp meter, the current meter on my multimeter isn't working. I thought I blew a fuse, but the fuse inside is intact, so not sure quite what happened. I might investigate that, but I'll take that back anyway. But thing that I thought of to test this out was I have this little what's it called, current, voltage and capacity tester, and a dummy load for the USB. So I just connected two wires to the DC output. I've got it set on 5 volts. It's saying 494 here, but these two switches here turn on these resistors. First one is 4.7 ohms and second one is 2.2 ohms. So at 5 volts it should give us 1 amp if the first switch is on, 2 amps if the second switch is on, or 3 amps if both switches are on. And we'll see how this goes, how the power supply handles it. Now I will turn on the fan now, because at the moment the power transformer is cool because no load is set, but when I push it up to 3 amps it's probably gonna get really hot. So I'll turn on the fan, and if you hear me a bit worse, that's because of the fan. But here we go. Hopefully it's not too loud on camera. So I have my amps set to max and my volts set to 5 volts. Let's turn on the dummy load. Let's first test 1 amp. 0.89. This thing is getting really hot. Let's push up the voltage a bit so we get the whole 1 amp. There we go, 1 amp holding for now. Transistor is getting warm. Let's try 2 amps. $188. I'll just push the voltage up. Yeah, that's 2 amps. Holding for now. It was probably 2 amps to begin with, but this isn't that. What's the name? That precise, yeah. This isn't that precise. So now let's try 3 amps. Ready? 244, 246. Let's bring up the voltage a bit. 250, 260, 299. Oh, 3.23. 3 amps. Let's go. There we go, 3 amps at 6.2 volts. The transistor is quite warm now. This one not that much, but yeah, as you can see, it's holding at 3 amps. These things are really hot, don't touch them with your hand. But let's try lowering the current potentiometer and see if we can put it into current, constant current mode. So I'm pulling the potentiometer down. There we go. LED went on and voltage starts to drop. It's at 225, 221, 220. This is gonna go below voltage for my meter, so it's 2 amps now. You can't see it, but I can see it from here. If I go down even lower, now it's gone. So everything seems to work fine. I'm really happy with the results. In the next videos I will play around with this a bit. Until then, thanks for watching and see you in the next one. Cheers.